Okay, let's talk about sequence and series and arithmetic. Okie dokie. So, to determine if it's arithmetic, there is a common difference. So I just find the difference of all the terms. So I start with 5 minus 1 equals 4, 9 minus 5 equals 4, and 12 minus 9 equals 3. These are all not the same. So this is not arithmetic. All right, let's do the same thing over here. Negative 7 minus negative 1 gives me negative 6. Negative 13 minus negative 7 is negative 6. Negative 19 minus negative 13 is negative 6. So all the differences are the same. So yes, there is a common difference. Okay, find the formula for the nth term. All right, well, the formula for the nth term of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d, where d is the common difference, and a sub 1 is the first term. Okay, so we see that a sub 1 is equal to negative 7. To find the common difference, I'll just use the first true terms. So d is equal to negative 3 minus negative 7, which is 4. Okay, so I take those and plug them into my formula. So a sub n is equal to a sub 1 plus n minus 1 times d. If I would just play with this and simplify it, a sub n is equal to negative 7 plus 4n minus 4. So a sub n is 4n minus 11. All right, so now I want to find the 31st term. So that means n is equal to 31. So a sub 31 is 4 times 31 minus 11. So a sub 31 is equal to 113. Okay, so find the formula for the nth term. Once again, I'm looking for a sub n equals a sub 1 plus n minus 1 times d. Okay, the first term is easy. So a sub 1 is equal to negative 100. And then d is equal to negative 89 minus negative 100, which is 11. Okay, so I plug these into my formula. So a sub n is equal to a sub 1 plus n minus 1 times 11. So a sub n is equal, and you can leave it in this form or put it in the other one, whichever is easiest for you. So negative 100 plus 11n minus 11. So a sub n is 11n minus 111. Then define the 47th term. That tells me that n equals 47. So a sub 47 is equal to 11 times 47 minus 111. So a sub 47 is equal to 406. Okay, so find the formula for the nth term of the arithmetic sequence where a sub 1 equals 5 and a sub 10 equals 50. All right, so I know I'm looking for a sub n equals a sub 1 plus n minus 1 times d. Okay, it tells me that a sub 1 is equal to 5. It also tells me that n is equal to 10. So given this information, I have to find the common difference. Okay, so I can use this formula and the fact that a sub n is equal to 50. A sub 10 is equal to 50. Okay, so that gives me, using this formula, 50 a sub n is equal to a sub 1, which is 5, plus n, which is 10, minus 1 times d. So that gives me 50 equals 5 plus 10d minus d. So 50 equals 9d plus 5. I didn't leave myself enough room, so I'm going to have to continue it up here. Subtract 5 from both sides. Excuse me. I get 45 is equal to 9d, so d is equal to 5. So I can use this information and come up with a sub n is equal to a sub 1 times n minus 1 times d. Oops, and that's plus. So a sub n is equal to a sub 1 plus, oh, and I know my d is 5, so let me replace that with 5. So that's a sub 1 plus 5n minus 5. Then I also know that a sub 1 equals 5. So a sub n is just equal to 5n. So now it's asking me for the 100th term. So if n equals 100, a sub n equals 5 times 100. So a sub 100 is equal to 500, and this should be a 100. Okay, so find the sum of the first 200 terms of this sequence. Okay, so let's see. The formula I'm going to use here is the sum of the sequence is n divided by 2 times a sub 1 plus a sub n. Okay, because I don't know what a sub n is. All right, so let's see what it gives me here. It gives me that a sub 1 is equal to 3. If I use these as my terms, d is equal to 6 minus 3, which is 3. So, so this gives me the formula that a sub n is equal to 3 plus n minus 1 times 3. So now I can find a sub 100. So, I'm sorry, a sub 200. N equals 200. So a sub 200 is equal to 3 plus 200 minus 1 times 3. So a sub 200 is equal to 600. So now I have everything I need for this formula. So n is 200, a sub 1 is 3, and a sub n is 600. So the sum of the first 200 terms is equal to the number of terms divided by 2 times a sub 1 plus a sub 200. That gives me 100 times 603. So S sub 200 is equal to 10,630. Let's put my 0 in the wrong place. Let me rewrite that. 10,000. That's why I couldn't do it. That's 60,000. Goodness gracious. 300. See, I can do all of the fancy stuff. It's the arithmetic that's tough. Okay, so to find the sum of this series. Okay, what do I know? I'm going to use this formula again. S sub n equals n over 2 times a sub 1 plus a sub n. So what do I know from here? So a sub 1 is equal to 5 times 1 minus 21. So a sub 1 is 5 minus 21 is negative 16. Then a sub 70 is equal to 5 times 70 minus 21. So a sub 70 is equal to 329. And I also know going from 1 to 70 that my n, there are 70 terms. So S sub 70 is equal to 70 over 2 times a sub 1 plus a sub 70. So S sub 70 is 35 times 313. So S sub 70 is equal to 10,955. Okay, I think there's too much to do on this one video, so I'll stop here.